So problem 23.14 is asking us about the magnitude of the electric field E at the midpoint between the two rings. So the first thing I did was draw the picture, writing down the information that the problem gives us, and it gives us that the ring on the left is negative 20 nanocoulombs, and the one on the right is positive 20 nanocoulombs, and that the distance between the two rings is 20 centimeters, which indicates that the midpoint will be at 10 centimeters. It also gives us that R, the radius of those rings, is 5 centimeters. So we were given in the book the equation for the electric field of a ring, which is at 1 over 4 pi epsilon naught times z times q over z squared plus r squared to the power of 3/2. And so we have enough information from the problem to pretty readily solve this. But before we do that, we're going to have to take account the fact that there's two rings here, and I'll talk about that now. So you can see in my really rough picture, hopefully, that a positively charged thing, the electric field is going to point outwards from it, where it's negatively charged, the electric field points inwards. So you can see that at that midpoint, that's going to lead to the charges, the electric field from the two plates adding together. So at that midpoint, all we have to do is double our E-ring equation in order to solve for that electric field at the midpoint. So once you do that, you get an equation you can plug everything into, and just really quick, you can see on the bottom of this, you can see what z and r are once again. So we just plug those in, as well as the known value for epsilon naught and all that, and we get a electric field at that midpoint of 2.57 times 10 to the 4th newtons per coulomb. So notably, it can be kind of tricky to remember. You have to be really careful about your units throughout this. For example, I had to change from centimeters to meters and also from nanocoulombs to coulombs. So always keep that in mind. So B is essentially just asking us to decide what direction the electric field is pointing. So you can see that in that really rough picture, again, those vertical components cancel out, and once again, the positive plate and the positive ring and the negative ring end up adding in the direction of the negative ring. So that electric field is going to be directed directly towards the center of the left ring. C is asking about the magnitude of the force on a proton located at the midpoint between the rings. So we already know the charge of a proton. It's just 1.6 times 10 to the negative 19th, and we just solve for that electric field. We can use that same value since the electric field is independent from that charge. So once you plug in, once you use that force equals charge times electric field equation, just plugging in those numbers, you get a force of 4.1 times 10 to the negative 15th newtons on that proton. Part D is just asking us about the direction of the force on the proton. And just I included the picture for a reminder of what our situation looks like. That force on the proton is going to be directed left. I thought about it just in terms of it's a proton and it's positively charged, so it's going to be pushed away from the positive ring and towards the negative ring. So that's how you can think about it. That's pretty much it. There's a few tricky parts. I think sometimes just drawing this picture and fully understanding the information that the problem's giving you, and correctly applying that to the equation, which is kind of the whole problem. But nevertheless, I think that can be the tricky part. Also, like I said earlier, always remembering to convert the values they give you to the correct units. But that's pretty much it. Thank you for listening.